and sharing the screen. And let me go to your class, not the preceding class. Today we're going to look at the last topic, quadratic applications, and also hopefully we'll have time to review today, looking at the problem set. And so that exam 4, I think on the schedule that I gave out at the beginning of the semester said the exam was going to be on the 19th. And so it'll be available from the 19th till Sunday the 22nd for you to work on. Before we start looking at that, I did get an email, a couple of email questions from students. I wrote them down. Here they are. So let's first go over the questions that I got emailed, which involved that idea of factoring completely. And the first example that I got in the mail was 3n squared minus 48n plus 192. Now, in order to factor, especially if there's a leading coefficient, it doesn't always happen, but sometimes we'll find that that leading coefficient is a common factor. So first thing I want to know is 3 a common factor? Can I divide 48 by 3 evenly? And the answer is yes, that gives me 16. And can I divide 192 by 3 evenly? And the answer is yes, that gives me 64. And so I have a common factor of 3. And when I divide it out, I'm left with n squared minus 16n plus 64. Now I have to look at the trinomial that's left, and I have to ask, can I still factor? And when I try to factor this one, because it has a leading coefficient of 1, it's a little bit easier to factor than some of the others. For n squared, my only choices are n times n. Because my last term is positive, I know that my signs both have to be the same, and they'll be subtraction. And so now I'm looking at the factors of 64, seeing which would give me 16. The 64 could be 1 times 64, but those don't add to 16. 2 times 32, but those don't add to 16. 4 times 16, but those don't add to 16. 8 times 8, yep, those add to 16. And so if I take negative 8 plus negative 8, they'd add to negative 16. So both of these will be 8. So final answer, I can write it like that, or I can write it like 3 times n minus 8 quantity squared. Thoughts? How's that one look?
When we enter that in the computer for the answers in the homework, should I just be entering n minus 8 squared?
No, you have to enter the entire thing. You need to put that factor of 3 in front. Because if the factor of 3 isn't not in front, it will not equal your original problem. You always want to make sure that you equal that original problem.
Okay.
The next thing that I received in the email is 2n squared minus 4n plus 2. Again, whenever I factor, I always see, is there anything in common? And here, because they're all even, there's a common factor of 2. When I divide out the 2, I'm left with 2 times parentheses n squared minus 2n plus 1. And I think that part factors. For n squared, it will be n times n. For 1, it will be 1 times 1. To be a positive 1, my signs have to be the same, both subtraction. but I can't lose that factor of 2. And so final answer, I can write what we have, or I can write it as 2 times the quantity n minus 2 squared. Again, you've got to put that 2 in there, because if that 2 is not there, it does not equal my original problem. That one better.
Yeah.
And so then last one I got was 2n squared minus 40n plus 200. And again, I'm always looking for a common factor. If I have it, it makes my life easier. Since they're all even numbers, I'll take out a common factor of 2. So that leaves me with 2 times n squared minus, whoops, it would help if I wrote the right number. Sorry, folks. Minus 20n plus 100. And now to see if that factors, again, I can't lose that 2. Because we have a leading coefficient of 1, in order to get n squared, it'll just be n times n. Multiplied to 100, add to 20, will be 10 and 10. The signs are the same to be positive. In order for that middle sign to be negative, they're both minuses. And so I can write it like this, or I can write it like 2 times n minus 10 quantity squared. Again, we've got to make sure we put that common factor of 2 in there, because if the 2 weren't in there, it would not multiply to our original problem. How's those?
Good, thank you.
Not bad.
Good. Then in addition to factoring completely, last class, we also looked at the idea of solving a quadratic equation, or solving an equation, not just a quadratic, but an equation with exponents on the variables. And in order to do that, we said that first of all, we wanted to make one side 0. Then we wanted to factor completely. And then we use the 0 multiplication property. Which said that if those things are going to multiply to 0, one of them had to be 0. So we use the 0 multiplication property to set each factor equal to 0. Which gave us several equations to solve. And then we always finish by doing a check. And if I remember correctly, we got through several examples of those. What I'd like to add today is using that process to solve word problems. Before we do that, does anybody want to look at any of the solving equations by factoring problems from the homework? And it will eventually come up here. Those would be whoops, sorry about that. I didn't mean to mute myself. So we had looked at we were looking at specials here, the homework that's due today. The other homework that's due today is this homework 30, solving quadratic equations by factoring. Does anybody want to look at any of those?
Yeah, go over some of them.
Okay.
Yeah, thank you.
All right. There's 16 of them. Let's see. An equation of that form, I think we had defined that as a quadratic equation. Hopefully that definition one is all right for everybody. To solve this equation, as I look at this one, these first couple that you're going to see in the homework, we've got it factored already. And one side equaling 0. So they've done the lion's share of the work for us. If that product is 0, that means that one of those two things that I'm multiplying is 0. So this is the idea that we're going to set each factor equal to 0, which gives us two simpler equations to solve. The first one gives me x equals 3. The second one solving gives me x equals -5. And so our solutions here, because there are two factors, we'll have two solutions. One is 3, and the other is -5. How is that one?
Okay.
Then next one is similar. It's factored already. You just set each factor to 0. This one is also similar. It's factored already. You know, some people lose their confidence a little bit with something like this. Here we've got x times x plus 8 equals 0. This side of the equation, I just have multiplication. So if those two equal to 0, one of the two of them has to equal 0. And so here one solution would be 0. And then solving on the other side, we'd get our second solution to be -8. That went all right.
Yeah.
This one again is already factored. We'll set each factor equal to 0. But now I get ones that are a little bit more involved because they're not factored. So here I have x squared minus 14x plus 40 equals 0. One side is 0, so that much is done for us. But now over here we have to factor this trinomial. How would you folks factor x squared minus 14x plus 40? I'll do the hard part. To get x squared, my only choices are x times x. If they multiply to a positive, in order for the product to be positive, should my signs be the same or different?
Same.
Okay, so here they'll both be negatives. And now I'm going to look at 40. What are numbers that multiply to 40 that might give me 14? 40 could be 1 times 40. That won't give me 14. Could be 2 times 20. That won't give me 14. 3 doesn't go in evenly. Could be 4 times 10. Will 4 and 10 give me a 14 if I add them?
Yes.
So I have x minus 4 x minus 10. And now to finish solving, if those multiply to 0, one of them has to be 0, and we don't know which. So we've got to set each factor equal to 0. And that gives us two easier equations to solve, yes? And I get x equals 4 from the first. And then from the second, if I go to solve that by adding 10, I get x equals 10. Did I put a smiley face next to that one? Is that all right for everybody?
Yes, thank you.
Then this is kind of similar, except with this one you have to be careful because your signs will be different, not the same. This one again is similar, where we've got x squared minus 14x equals 0. I've got an exponent, so I know I have to factor. One side 0 already. But when I look at factoring what's on the left, does everybody remember that usually when we factor, we say, is there anything in common? And on the left, is there anything in common?
X.
Beautiful. And so I'm going to take out that common factor of x, which will leave me with x minus 14. And then from here, is everybody all right? Finishing this on your own by setting each factor equal to 0. Do that and tell me what you get for solutions. Give me a second, folks. I'm sorry. Hello? Okay, I'm in the middle of teaching a class. Do you want to give Daddy a call instead? Okay, love you. Bye. Sorry about that. What do you guys get?
X equals 0 and x equals 14.
Yes, 14. And I miswrote and copied it as 4 instead of 14. Sorry about that. So let's skip up. I got to turn my finger back into a mouse. This one's a little bit different in that one side is not 0. And so here, if one side is not 0, we've got to make that right-hand side 0 first by subtracting the 121 from both sides. That gives me x squared minus 121 equals 0. Now we can factor. On the left, there is no common factor, but there's only two terms. Does everybody remember that it will only be factorable with a binomial if they're both squares and it's a subtraction? And so I guess my question is, can anybody recognize what number I square to get 121?
11.
And again, because it's a negative, one will be a plus and one will be a minus. And then from there, is everybody all right going on and finishing it by setting each factor to 0 and solving? I'm going to leave that one for you folks to finish in the homework. And let's go on and look at a couple more. This one again, we do not have 0, so we'd have to subtract 40 from both sides, and then we can factor. This next one side is 0. We just kind of have to work, and this one's a little bit more involved solving because we've got a leading coefficient other than 1. I think you folks chose to factor those using the AC method, but that should be factorable. Next one, this one's very much different. It's a little different than the ones we looked at in class. We've got x minus 1 times x plus 3 equals 12. This is not 0. So we cannot just go ahead and set each factor equal to that number. We need to first multiply this out first, x squared, outer plus 3x, inner minus 1x, last minus 3, to get x squared plus 2x minus 3 equals 12. And then we have to subtract the 12 from both sides to make one side 0. X squared plus 2x minus 15 equals 0. And now, because one side is 0, we'll factor and then set each factor equal to 0. So I know this one's a little bit more involved than the ones we did in class because it didn't start in that standard form. We want it to be there first. So here, for x squared, it's x times x. To multiply to 15, I think my only choices are 1 and 15, or 3 and 5. Because it's a negative 15, I want different signs. And so if I take negative 3 times positive 5, that'll give me a negative 15. And if I take minus 3 plus 5, it'll give me that positive 2 in the middle. So when I said each factor equal to 0, I get x can equal 3, or x can equal negative 5. And I would have to go through and check both of them in the original. So that one is a little bit more involved. Are you folks comfortable with that one?
Yeah.
All right, then I believe that, oh, this one is great fun because as I look at this one, do you notice I'm starting with x to the third? And because it's got x to the third, in my mind, I'm thinking I should expect 3 solutions. And so to find them, I'm in descending order. One side is 0, so I have to factor. But is there a common factor on the left? Anybody?
X.
X, beautiful. And so when I factor out that x, I'm left with x squared minus 10x plus 16, still equaling 0. I can't lose my common factor. To get x squared, it's going to be x times x. To get 16, it's a positive 16, so my signs are the same. 1 and 16 don't add to 10. 2 and 8, well, 2 and 8 do add to 10. If I make them both negative, negative 2 times negative 10 do multiply to positive 16 and add to negative 8. I'm sorry, and add to negative 10. I apologize, I misspoke. And now I have to set all 3 of the factors equal to 0. And with solving, this one gives me x equals 0. Adding, this one would give me x equals 2. And in the same way, adding, the third one gives me x equals 8. And you see how, because it was third degree, we did indeed get 3 solutions. How fun is that? I can hear your joy, folks. Everybody okay with that one?
It's all so easy when you show us. That's the thing.
Yes.
I sail along and I think, oh, this is easy. I can do it. Yep, I can do it. And then I'm like, I think too much over it. I think it's more simple or simplistic than I think it is.
Can I tell you that if I can do it, it really can't be that bad because there's nothing special going on here. More than brighter than I. The only difference between me and you is that I've been doing these a lot more than you have. And what takes you to that point is that fact, which is why I heard somebody sent me an email when I sent that sheet of 100 factoring problems. Did y'all get it?
Yes, thank you.
Work on them. You know, do them like you would do a crossword puzzle or a Sudoku. Flip over from one side to the other. Practice multiplying. Practice factoring. Because again, with this factoring, it's that idea that the more you practice, the better you get. So, enough of these equations to give you an idea.
Yes, thank you.
All right, then I'm going to clear this and get out of the homework and go back to the notes. And wow, I love the way they interpret my bad spelling, right? Because it's supposed to have text recognition. Do you notice my messy solving an equation with turned out to Sovino and count on Withy? Oh dear. Today what we're going to look at is, yay, problem solving. And when I look at problem solving, which we've done already, first directive is always to make sure you read carefully. Second, there's usually many ways of solving a problem, but because this is an algebra class, we're going to try to solve them algebraically. And so we're going to need variables. And so we have to always define our variables. And that involves those let statements. And I'm going to stop for a minute because amazingly the sun is coming through my window and shining on this surface, which I think helps it overheat sometimes. So I just have to reposition myself. There we go. Then we're going to write an equation to relate the variables. I'm going to add in here sometimes a picture's worth 1,000 words. Draw a diagram. And then after we have our equation, we'll solve it. And then what's different with these applications, these word problems, is we're not going to check in the equation, but we're going to check in the situation. We can't just substitute into our equation to do our check because we made up the equation. And so we're not just checking to see if we solved our equation correctly, but we're also checking to see if we wrote the right equation for the situation. And so we've always got to check against the words of the problem. and not just by plugging in. And so I'm guessing that that's probably about as clear as mud. And so I uploaded into the notes several word problems that we're going to look at today. Then, after we go through these word problems, hopefully we'll have enough time to do a little bit of review, looking at that problem set to give you an idea as to what will be on that test. All right?
Is that
Right.
problem set number 4?
Yes.
Okay, thank you.
So I'm going to go over here, and the reason these are numbered oddly is because I pulled them out of the virtual textbook and cut and paste them into this worksheet. I chose them because they somewhat resemble the questions you'll see in this homework. And so the first one says the area of the rectangle is 84 square inches. Find its length and width. Does everybody see that with this problem, we're already given a diagram? And while they didn't write it, does everybody see that one dimension? We could say x plus 3 is the length, and x minus 2 is the width. Is everybody all right with seeing that from the diagram?
Yep.
Now, I'm going to go on the assumption that this is not the first math class that you folks have ever taken. And so I'm wondering if somebody can help me remember how to find the area of a rectangle. Anybody remember?
Length times width.
Beautiful. Length times width. So here we know the area, 84, is equal to the length, x plus 3, times the width, x minus 2. Now this looks an awful lot like that problem that we had, where one side was factored already, but we didn't have 0. And so in order to solve this equation, first thing we're going to have to do is multiply out what's on the left. Take that back. That's not my left, that's my right. Multiply out what's on the right. First, x squared, outer, minus 2x, inner, plus 3x, last, minus 6, gives me 84 equals x squared plus x minus 6. Now, because we've got that exponent, we want to make the other side 0. And I have to apologize, I've run out of space, so I'm going to scooch over. That gives me 0 equals x squared plus x minus 90. We've got to factor that. I'll do the hard part. X squared can only be x times x. Now, remember, for just a minute, we're going to ignore the middle and look at the end. What numbers can I have that multiply to negative 90? Any ideas? What can multiply to 90?
10 times 9.
Beautiful. And if I look at 10 times 9, because it's a negative 90, one's going to be a positive and one's going to be a negative. And do you guys see that in order to get, now I'm looking at that middle, that positive 1. If I have positive 10 and negative 9, wouldn't those add to that positive 1? So I get x plus 10, x minus 9. If they multiply to 0, then x plus 10 can equal 0, or x minus 9 can equal 0. First one we'd subtract and get x equals negative 10. Second one we'd add and we'd get x equals 9. Oh, I'm sorry. I said equals and that's not what I wrote. I apologize. I have issues though. X has to be part of a side of a rectangle. If x is negative 10, my length would be negative 10 plus 3 or negative 7. Do you ever get a negative number when you use a ruler to measure a side?
No.
No. Length is another negative, so we're going to reject this. And we're going to use that 9. So I'm going to go up here because I've run out of space and erase this. If x is 9, the length would be 9 plus 3, or 12. The width would be 9 minus 2, or 7. And so my check, the area is length times width, and 12 times 7 is 84, and so it checks. And so do you see how in order to check, I did not go back to my equation. I went up back to the words of the problem. How's this one?
So is the correct answer all the factoring that we did in the middle? Or could we just figure it out, do the A?
Figure that x is 9, but the question asks for the length and the width. And so the length and the width are 12 and 7. So let's want to make sure you're answering the question asked. Can I slide that one up and look at the next one? Or do we need a minute more on this one? Does anybody need more talking through with this one? Are we all right? I'm not hearing anything, so I'm moving down. Next one says an object is thrown upward from the top of an 80-foot building with an initial velocity of 64 feet per second. The height h of the object after t seconds is given by the quadratic equation h equals negative 16t squared plus 64t plus 80. When will the object hit the ground? So a couple of things we need to know here. We need to know that h is the height of the object. Now, we're wondering when we hit the ground, right here, when it hits the ground, how high is it? How high off the ground is it when it's on the ground? How many inches up in the air is it when it's, or I apologize, how many feet up in the air is it when it's on the ground? If we were in the classroom, I'd take my pen and I'd throw it up, and everybody would watch it go up and fall on the ground. And we'd all look at it on the floor. And we'd say that on the ground, the height is 0, right? It's not off the ground at all. And so when it hits the ground, the height is 0. T is the time in seconds. And that's what we're looking for. With this one, we don't need to write an equation because we're given in the equation h equals negative 16t squared plus 64t plus 80. And all we have to remember is that when we're on the ground, h is 0. So resolving negative 16t squared plus 64t plus 80 equals 0. One side is 0. We're in descending order. So first we're going to have to factor. Is there anything in common? What's the biggest number that goes evenly into 16, 64, and 80? Any ideas? A number that can divide all three of those. Not just any number, but the largest number.
8.
I'm thinking we can even go bigger than 8. I'm thinking they all divide by 16. And because this leading one is negative, let's take out a negative 16. So I want to think of taking each of these and dividing them by negative 16. And that gives me 0 equals negative 16 times, that would be positive t squared minus 4t minus 5. So that's negative 16. If we factor further, t squared would be t times t, to be negative. One's a positive, one's a negative. 5 is only 1 times 5. And if I take positive 1 and negative 5, when I FOIL that out, they'll add to that negative 14 in the middle. When I set them equal to 0, I get negative 16 equals 0, which makes no sense. I get t plus 1 equals 0, which gives me t equals negative 1. Can we have negative time?
No.
No. So time's not negative. And so here, when I take t minus 5 equals 0, if I add, I get t equals 5. And so that better be my answer, that it takes 5 seconds to reach the ground. Does anybody want to climb on top of an 80-foot tall building and time throwing something in the air and see if that 5 second works? Is that one all right? I think the trickiest part with this one is realizing that if I'm on the ground, my height is 0. I know some people stress over where the hell did that equation come from? And you really don't have to worry about where that equation comes from. They're telling it to you, so you can trust them. If you're interested, in pre-calculus and calculus, people are expected to come up with equations like that. And you get over here that the 80 comes from the height of the building, but the 16 and the 64 actually come from the effects of gravity on something. So always interesting. But next one. Uh-oh. Does anybody else want to read this one? Wow, the spirit of volunteerism is overwhelming.
So we should draw a diagram like the first one.
Yeah, let's draw a rectangle. I like it. We know that the area is 120. Now, what do we know about the length and the width? Told the width is 7 less than the length, right? And so because the width is being compared to the length, I'm going to let x equal the length. Now, if the width is 7 less than means subtract. And so x minus 7 would be the width. And now we know that area equals length times width. And I apologize, I wrote that too fast. Does this part over here, let it, if x is the length, because the width is 7 less, having that be x minus 7. Does that make sense for everybody? Hearing no complaints, I'm going to be quiet and I'm going to ask you folks to please finish this. I'll give you a couple minutes and then we'll go over. How are you folks doing? Did anybody else get the dimensions of that rectangle to be 15 times 8?
Are these on the test?
I believe there might be 1 or 2 word problems on the test, yes.
Okay.
How does this one look? I think probably the hardest part is coming up with factors of 120 that give me that 7 in the middle. Not gonna lie, I started with the obvious 12 and 10, 6 and 20, and realized that they didn't work. And then I had to start playing around with the numbers until I got 15 and 8. Is everybody comfortable with this one?
I get it, but I don't love those word problems, so I'd have to do a bunch on my own.
There's an assignment that's just word problems.
Oh, good.
And I realized this morning that I had not adjusted its due date, so it was initially also due today. And I thought, oh no, we didn't do them yet. So I changed it so that the word problems are due on Thursday. Next one says a ladder is leaning against a building so that the distance from the ground to the top of the ladder is 1 foot less than the length of the ladder. Find the length of the ladder if the distance from the bottom of the ladder to the building is 15 feet. And they have this picture drawn for us. Does everybody see that based on their picture, they're letting x equal the ladder, and they're letting x equals 1 be the ground to the top of the ladder. I want to change that picture up just a little bit. Mine's not going to be as artistic, but they're saying that the building is straight. So I've got a right angle here. The ladder is x. To the top of the building is x minus 5. And what they didn't put in their picture is that this on the bottom is 5. Now, in order to solve this problem, what you have to realize is we have a right triangle. And in a right triangle, has anybody heard the word hypotenuse? The hypotenuse is the longest side. It's opposite the right angle. And so in this problem, the ladder is the hypotenuse. The other two sides are called legs. And I'm going to write over here on the side. There's something that's called the Pythagorean theorem. It only works in a right triangle. And do any of you remember hearing of the Pythagorean theorem before?
Yeah.
Vaguely.
it's something like a squared plus b squared equals c squared, where a and b are the legs, and c is the hypotenuse. And so, going back to the problem at hand, because it's a right triangle, I know that a squared plus b squared equals c squared. C is the hypotenuse, it's the ladder, it's x. The other two sides, the 5 and the x minus 1, are my legs. Over here, we have to simplify what's on the left. Doing so, I'll do the hard part. 5 squared is 25. The other part, when I look at x minus 1 squared, remember that's x minus 1 times x minus 1. And when I work that out, it gives me x squared minus 2x plus 1. And that equals x squared on the other side. Well, 25 and 1 is 26. So I've got x squared minus 2x plus 26 equals x squared. Because of this x squared, we're going to make one side 0. So we'll subtract x squared from both sides. That gives me negative 2x plus 26 equals 0. And now, do you notice when I look at this equation, there's no x squared left? So to solve that, negative 2x plus 26 equals 0. I don't have to factor because there's no exponent. So I'll add 2x to both sides, which gives me 26 equals 2x. And when I divide by 2, I get x is 13. So my ladder is 13 feet. It's going up 13 minus 1, or 12 feet on the wall. And if I do my check, 5 squared plus 12 squared, does that equal 13 squared? 5 squared is 25. 12 squared is 144. 13 squared is 169. And these guys do indeed add to 169. So it checks. And it's an interesting problem because it uses the Pythagorean theorem. But does anybody question how you can know that there's a 1 foot difference in that distance, but not know how long your ladder is? I don't know. I think you'd know the length of the ladder first, wouldn't you? Sorry, but I digress. I'm being silly there. That's probably the most challenging one you'll find in the home. And there will be one in there similar to this. Last one's kind of fun. It says, at the end of 2 years, P dollars invested in any interest rate R, compounded annually, increases to amount A, given by A equals P times 1 plus R in parentheses squared. They want you to find the interest rate if $100 increases to $144 in 2 years. So that $100 is what we're investing. So that's P. That 144 is what we get in the end. So that's A. And we want to find R. We know that A is equal to P times 1 plus R squared. So we know that 144 is equal to 100 times 1 plus R squared. This side is not 0. So I think we need to work this side out. We need to simplify it. So I've got 144 there. I've got 100 times order of operations. Shouldn't I do my exponent first? And so scrap paper. If I take 1 plus R and square it, that's 1 plus R times 1 plus R. It gives me 1 plus R plus R plus R squared, or in order R squared plus 2R plus 1. That gives me 100 times R squared plus 2R plus 1. I think now we have to distribute. 144 equals 100 R squared plus 200 R plus 100. I'll subtract that 144 from both sides, because since we have an exponent, we need to make one side 0. Now we have to factor. There's a common factor of 4. Leaves me with 25 R squared plus 50 R minus 11. I'm going to do this by trial and error. That 25 R squared, I'm going to use 5R times 5R. 11 can only be 11 times 1. If I make it positive 11 and minus 1, when I FOIL, first is 25 R squared, outer is minus 5i. Inner is plus 55i. Last is minus 11. So I do get that 50r in the middle. When I set each factor equal to 0, four does not equal 0. Here, if I subtract 11, I get 5r equals negative 11. And when I divide by 5, I get a negative interest rate. What is that? If I divided that out, that would be negative 2.2. And we don't have a negative rate. So here, if I add 1, I get 5r equals 1. And when I divide by 5, I get r equals 1/5. Because it's an interest rate, I'm going to divide that to a decimal, 0.20, and change it to a percent. So we would need an interest rate of 20%. Interesting? So those were the examples that I wanted to look through today. Beyond those examples, the other thing that I wanted to do today was work through a problem set. And I think we have a half an hour in which to do it. Are you guys game?
Yep.
Yep.
Good.
Yep.
Now, problem set number 4 on chapter 13. Let's preview it. I'm going to just write on the page. First thing, ask for the GCF, and we've got 147, A to the 5th, B to the 3rd, C to the 7th. And we've got 63, A to the 6th, B. We've got to find a number that goes into both 147 and 63. How would you folks do that? Would you make your factor trees?
Yeah.
Okay. What goes into 147? I'm seeing 14 and 7, so I think 7 does. 147 divided by 7 is 21. What goes into 21?
7 times 3.
Beautiful. And so what we've got here is 7 to the 2nd, 3, A to the 5th, B to the 3rd, C to the 7th. Now how about 63? I think that's 7 times 9. And 9 is 3 times 3. That gives me 7 to the 1st times 3 to the 2nd times A to the 6th times B. So what's the common factor? The greatest common factor. What shows up in both the lists? They both have a 7. They both have a 3. They both have an A. They both have a B. Remember the common factor? We look what they have in common and we use the lowest exponents. The lowest exponent on 7 is 1. Lowest exponent on 3 is 1. Lowest exponent on A is 5. Lowest exponent on B is 1. And so my common factor is 21 A to the 5th. Does everybody remember finding those common factors?
Yeah.
Then let me clear that. Can I clear it or do I need to wait a minute? Everybody all right if I clear?
Yep.
Next, asks you to factor the greatest common factor. And all we're looking for here is that common factor, nothing more. From 28x to the 5th, 16x to the 3rd, 20x to the 4th, and 12. They don't all have x's, so that's not going to be in common. Can anybody tell by looking a number that goes into 12, 28, 16, 20, and 12?
4?
I like it. So our greatest common factor is going to just be 4. And to factor it out, we're going to think of dividing each of these by 4. So our common factor is 4. That's what they mean by factored form. They want us to show the product. And the other factor would be 7x to the 5th plus dividing here, 4x to the 3rd, dividing here, minus 5x to the 4th, and dividing here, plus 3. How's that one? Can I clear it?
So that's the answer that we'd enter into that box.
Yeah.
Okay.
Factor the following 4-term polynomial. And over here, the key words are by grouping. When I'm factoring by grouping, it's always got to be 4 terms. And when I think of factoring by grouping, honestly, it's so silly. It reminds me of multitasking. I can't do 4 things at once, though. So I'm going to split it in half and do 2 at a time. So if I just look at this front half, what do they have in common? What goes into both 6 and 18?
6.
Beautiful. And so when I factor out the 6, when I divide it out, I'm left with x plus 3. Then I do the same on the back side. What do these two guys have in common?
Why?
Beautiful. You're telling me why and not asking why, right?
Both, but yeah.
Yeah. Dividing out the y, I'd be left with x plus 3. what do the two sides have in common? Don't they have in common x plus 3? And when I take away the x plus 3, wouldn't I be left with 6 plus y? And so that's my factored form. I like factoring by grouping. I think it's kind of fun because when you get to this point where the two things look the same, you know you did something right. We all right with this one, folks?
Yep.
Great. Next then asks you to factor completely. And when I see that word completely, I immediately think to myself, I should not be shocked if I've got to do more than one type of factoring. And I'm always first looking for something in common. And whenever I see that they're all even numbers, I know that at least there's a 2 in common. When I divide out that 2, I'm left with x squared plus 16x minus 36. And now I'm wondering, can I find factors of 36 with different signs that'll give me 16? I kind of like putting them in order. 36 is 1 times 36. That won't give me 16. It's 2 times 18. Well, with different signs, if I have -2 and positive 18, won't that give me that positive 16 in the middle? So again, don't lose your 2. X squared is x times x. -36, if we think of that as -2 times positive 18. When we check by FOIL, it should give me that 16x in the middle. How's that one? Is it all right if I clear it? Then let's look at the next. And again, it asks me to factor completely. I have 6x squared y plus 72xy minus 42y. When I see that word completely, I always start by saying, is there anything in common? They all have a y. And how about number wise? Does 6 go into 72 evenly? Yep. Does 6 go into 42 evenly? Yep. So my common factor is 6y. And when I divide this by 6y, I'm left with x squared. When I divide this by 6y, I'm left with 12x. And when I divide this by 6y, I'm left with 7. Now, are there factors of 7 that will give me 12? And I'm thinking 7 is only 1 times 7, which is never going to lead to the 12. And so this one, while the trinomial part is prime, the whole thing is not prime. it does factor, but only factoring we get is that common factor. All right,
So that's the final answer, the 6y, because it, okay.
the whole thing, the 6y times the x squared plus 12x minus 7. Because again, when we write our factors, we've got to make sure that everything we write, if I took the time to multiply it back, would take me back to the beginning problem. Let's look at the next. Next says factor completely. And we've got 22y squared minus 37y plus 15. And I think here we could do trial and error. And I can see it work in trial and error. But let's go through and let's look at it, because I'm guessing you guys use the AC method. So A times C would be 22 times 15, which I think gives me 330. $330 is 1 times 330 is 2 times, so something ugly like 165 is 3 times 110. I don't think 4 goes in there. Is 5 times 66 is 6 times 55. I don't think 7, 8, 9, 10. I think 11 goes in there 30 times. And you know what? Maybe I'm mistaken. Maybe that 1 is prime.
So ultimately no solution.
So I am thinking that this is,
What about,
unless, does anybody see any factors of that I've missed? Oh, wait a minute. Yes. How about 15 and 22? Minus 15 minus 22 does give me 37, right? So this would be 22y squared minus 22y minus 15y plus 15. I missed the obvious. Doing my grouping, I have 22y times y minus 1. In the back, I have 15y times y minus 1. And so factored form would be 22y minus 15 times y minus 1. I almost blew that one for you guys. How did I miss the obvious? Because 22 and 15 add to 37, don't they? Ready for the next one?
that's one that would confuse me, that I wouldn't want to include the 22y, but, oh, yeah, never mind. I see it. 22y is part of the factor.
Yep.
Factors, yep, got it.
Okay. All right. Then let's go on to the next. Next one we have 3x squared minus 63x plus 231. I see that word completely, so I'm wondering, is there anything in common? Anybody have a calculator with them? I'm thinking 3 is a common factor. Dividing this by 3 gives me x squared. 63 divided by 3, well, that's 21. And then over here, 231 divided by 3, I think is 77. Can somebody check my division?
Yep.
Yep. And so now we've got a common factor. Let's see, x squared is only going to be x times x. 77, I think that's 1 times 77. I think that's 7 times 11. Will either of those give me that 21 in the middle? So I think the only thing we're going to get from this one is that common factor. All right?
Yep.
Factor completely. 81 p to the 4th minus 234 p to the 3rd plus 169 p to the 2nd. Anything in common?
Maybe like 9p.
Well, I know 9 goes into this. I'm thinking
No.
I think 9 will go into this because those add to 9. I don't think 9 goes into 169. Do you want to check for me?
Oh,
So I think it's p squared, which gives me 81 p squared minus 234 p plus 169. Oh, this is ugly. I said it out loud. Don't let them hear me say that. Does anybody notice that 81 is a perfect square? Wouldn't 81 be 9p and 9p? How about 169? Does anybody recognize 169 as a perfect square? You guys didn't have to memorize your squares as a little kid.
13.
Yeah, that's 13 squared. What's 13 times 9? $117.
17.
And if I take 117 twice, I get 234. And so this one is p squared times 9p minus 13 squared. These questions are algorithmically generated. Usually when you look for one that involves a perfect square trinomial, you don't think of numbers like 9 and 13. Man, that was a little ugly, wasn't it? So,
Yes.
may get anybody's head that they're both perfect squares, so let's go through and try that. Next. Factor by grouping. Okay, grouping isn't too bad. I'm going to be quiet and ask you folks to do the grouping here. Just remind you that we're splitting it up the middle. How'd you guys do? Everybody got it?
I got to the middle, but then I had trouble getting to the end.
Did you get that both of them had that 3x squared minus 4?
Yeah,
So that's my common factor. And then to find the other factor, I almost think if I cross those out, what's left?
yeah,
The squared plus 4. Okay?
Yeah.
Then next, we have x squared y squared minus 4xy plus 4. Now this one, I don't see anything in common all the way across the board. Do you guys? But do you guys notice that this first one is a square? xy times xy. How about here? Is 4 a squared? Wouldn't that be 2 times 2? Signs are the same, both minuses. And if we go through and check it, we'll get that that's our final answer.
how did we get to the XY and the XY?
Because this is a square,
Oh, okay,
okay? And then 4 is a square, 2 and 2. And when I start and end with squares, that's when I think that I'm going to try those, that's perfect square binomial.
Okay. I
Okay?
guess I was thinking unless it told me to do that, wouldn't.
No, well, it's like that 81 and 169. It didn't
Right.
use squares, but it did kind of jump up and bite us on the nose that they were squares, right?
Yeah.
So,
And then it's easier, you just can figure it out like a shortcut almost.
if you recognize the squares. And it doesn't always work with squares, but most time it does.
Okay.
See, where are we going next? Ooh, this one's fun. What makes this one fun is that there's two terms. Does everybody see that they have an X in common? And then I have squares, but you see how there's only two of them? But you remember if there's two of them with squares, if it's minus, to get 25y squared, it'll be 5y and 5y. To get 36, it'll be 6 and 6. But because it's a minus, remember one's a plus and one's a minus. And that's our difference of squares. Next, to solve the equation, this one is really tricky because we've got x squared equals 81. And some people try to take a shortcut and say, oh, I know what squared gives me 81. It's 9. You have to be careful. You don't want to think that way because it's squared. If I make one side 0, that's the difference of squares. It factors into x plus 9 times, x minus 9. And when I set each factor equal to 0, I get two answers. I get the 9. That was obvious. But be careful. Don't I also get a second answer of negative 9? So here we're going to get two answers, both positive 9 and negative 9. All right?
So what would we put in that box? Would we put
Good.
not -9 comma? Oh, I see.
You type in, let's see. Let me pull up my keyboard and let me pull up my keyboard again and type in 9. They tell you to put a comma in between. There's 9, negative 9. Yay, we got it. Okay?
Yeah.
Solve the equation. I'm looking at this one. And does everybody notice there's no exponents in this one? I think we're just going to, what would you do first? Maybe distribute 2x minus 6 equals 7. Let's add the 6. gives me 2x equals 13. And I get x equals 13 has. That one's a blast from the past, isn't it?
Just to trick us.
Exponents, so don't worry about factoring it, okay? Ooh, now this one I think is pretty much like one of the equations we did already. We've got x to the third from the homework minus 10x squared plus 21x equals 0. One side 0, so I have to factor anything in common.
X.
Beautiful. When I take that out, I'm left with x squared minus 10x plus 21. Let's keep the x. And how do you think we're going to split up 21 to get a 10 in the middle? Signs are the same. Both are minus. What numbers multiply to give us 21?
Seven and 3.
So now setting each one equal to 0. I get x equals 0. Here, when I solve it, I get x equals 7. And the last one, when I solve it, I get x equals 3. So my answers would be 0, 7, 3. All right? And now I am torn because I'm looking at the time and our class time is up. I had hoped to get through that whole thing today. And I want to give you a heads up. There is a chance that I will not be here on Thursday. We've done most of this practice test together. Please work on it on your own. Whether I'm here or not on Thursday, that test will be open for you from, I believe, from Thursday until Sunday. If you have any questions, please, please, please send me an email. If I'm not going to be here Thursday, I'll send you an email Wednesday night. There's a chance that that might happen. Okay? Go through them slowly. If you have questions, let me know and I'll try to meet with you outside of class time. I can't help you with the test proper, but I can help you with the practice test and I can help you with the homeworks. All right? Any questions?